Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of linear inequalities. So we are solving the last few questions here. Alright, so most of the things you already know. If you do not know, please go back and watch those videos first and then come back to this class. So you know the meaning of modulus of x plus 3 is greater than or equal to 10. So this is a pretty straightforward question. There is no confusion here. So what do you mean by modulus of x plus 3 is greater than or equal to 10? So the meaning of that is either x plus 3 is greater than or equal to 10 or x plus 3 is less than or equal to minus 10. So that's the meaning of this. Imagine you take any value less than minus 10, minus 11, minus 12. So if you put minus 12 plus 3 is minus 9 and modulus of minus 9 is 9, and that is okay, so 1 second. So that must be greater than or equal to 10, the total quantity. Fine. So now x must be, I'm sorry, 1 second. So this is minus 10 minus 3, which is like minus 13. Okay. So less than minus 13 you have to put. So minus 14. So if you put minus 14 here, then what will happen if you put minus 14? So minus 14 plus 3 is minus 11, modulus of minus 11 is 11, which is greater than or equal to 10. So that satisfies, correct? So either it must be less than or equal to minus 10 or it must be greater than 10. So greater than 10 means x is greater than or equal to 10 minus 3, right? So that means x is greater than or equal to 7. Now you put any value greater than 7 here. You put 8. 8 plus 3 is 11, modulus of 11 is 11, greater than or equal to 10, right? So it satisfies. Therefore the solution is x should be less than minus 13, alright, so or equal, so this is closed, less than, or it must be greater than 7, and that is also closed that way. Okay, so it must be greater than 7 or it must be less than minus 13. So when you combine both, it is or. Okay, so you can group them together with a union. Okay, so you can write both the intervals with union, because this is not and, we are not finding the common region. There is no common region here. Okay, either this region or that region, so we can combine them using union. So please keep that in mind. It is not and. Therefore x belongs to, see, negative infinity till minus 13 you can go, and you can include 13, minus 13, union, you can start with the 7 is also included, and you can go up to positive infinity. So minus infinity to minus 13, okay, minus 13 is included, and then 7 to infinity. So this is the answer, and that's in the option C. Therefore option C is the answer. This is not the answer, alright, because here minus 13 is not included, whereas equal sign is present here, equal sign is present here as well as here. So minus 13 is included. Okay, it must be closed bracket. Well, so that is about question number 16. Let's quickly move to question number 17. Look at this question number 17. You have got modulus on both sides, so it's not that easy to simplify. So take it on one side, then we can work with the equation there. Alright, so 17, you just take the modulus 2x minus 3 minus, you are bringing that to the left hand side, and that is less than 0. Okay, so work with this inequality. We have already worked a question with positive sign, including two things within the modulus, remember? Yeah. Well, so how do you do this? See, if 2x minus 3 is equal to 0, what is x? 3 by 2, right? So that becomes plus 3 and divide by 2. Well, and then you have if this is 0, then x is equal to minus 5. So what are the critical points here? The critical points are minus 5 and 3 by 2 are critical points. So in these points, alright, so in these points you will have to break the real line. Understand? You have got the real line and you have minus 5 and 3 by 2. Okay, so the intervals would be minus infinity to minus 5 and then minus 5 to 3 by 2 and 3 by 2 to infinity. So totally 3 intervals, and in these 3 intervals you have to have 3 cases and check for the values of x. Alright, so this is a very tedious job. Alright, so let's begin. Now what is the first interval that we have? Minus infinity comma minus 5. So let's go for that. So the intervals are minus infinity comma minus 5, the first one, and the second one is minus 5 comma 3 by 2, and then the third one 3 by 2 comma infinity. Okay, so those are the intervals, and in those intervals we are checking for the values of x. So let's do it. First case, you have x in between minus infinity to minus 5, right? So in this interval, what is 2x minus 3? Take any value less than minus 5. Less than minus 5 is minus 6. You put minus 6. So if x is minus 6, then what happens to this? Minus 12 minus 3 minus 15, which is less than 0, correct? So if it is less than 0, that means if 2x minus 3 is less than 0, that means you have to write negative of it, is it not? And then minus. Alright, now in the same value, with the same value, what happens to x plus 5? So x plus 5, that means minus 6 plus 5 will be minus 1, that is also less than 0. Therefore you have to write negative of x plus 5, and that should be less than 0. Well, so this is minus 2x minus 3, and minus of minus will be plus, correct, minus and minus, and then x plus 5. So minus 2x plus x is minus x and plus 2. So what you can do here is take this minus x to the other side, that means you are adding x both sides. So if you are adding x both sides, inequality does not change. So 2 is less than x, that means x is greater than 2, correct? So x is greater than 2 and x is less than minus 5, understand? So you have 2 and then minus 5. So one interval is this, okay, till infinity, and the other interval is greater than 2. Greater than 2 is that part. Now do you have a common region? Okay, so do you have a common region? Both must satisfy. When this happens, that must happen. Alright. So, does it happen? Does it happen? No, it does not happen. If x is less than minus 5, it is not greater than 2. The same value of x. So, do you have a common region? You don't have. So, this is not possible. Alright. So, this case is not possible. So, we are not getting any solution here. Alright. So, we are not getting any solution here. Therefore, go to the next one. So, go to the next one. So, what is the second case? Second case is the second interval. So, minus 5 less than x less than 3 by 2. So, if x is in between this interval, then what happens? So, let us check. So, here you have got between minus 5 to 3 by 2 you can have 0, correct, negative and positive, in between there is 0. So, easiest is put 0. So, if x is 0, what happens to 2x minus 3? 0 minus 3 is less than 0. So, negative means you have to write negative of 2x minus 3. And then what happens to x plus 5? If you are putting 0, that will be positive, correct. So, that will be positive. If you have doubt, you can put minus 4. So, if you have minus 4 also, that will be positive, correct. If you put minus 4 here, it will be still negative, right. It satisfies for any value in between, alright. So, that is positive. That means you do not have to write negative of it, positive itself, same quantity is less than 0. Well, simplify. So, minus 2x plus 3 minus x minus 5. Right, and then you have minus 3x minus 2 less than 0. So, 3x can be taken to the other side. So, 3x is greater than minus 2, x is greater than minus 2 by 3. So, x is greater than minus 2 by 3. So, now once again understand. So, you have 0 minus 2 by 3 greater than, alright. So, till infinity. So, that is the white region, this region, and between minus 5 to 3 by 2. Alright. So, that is other region. So, what is the common? Yeah, you have common. The common is between minus 2 by 2 to 2 by 3 to 3 by 2. Okay. So, that is the common region. Therefore, we get a solution in second case. I will write it here. So, what is the solution we are getting? The solution we are getting is x belongs to minus 2 by 3 comma 3 by 2. So, from the second thing we got a solution. First thing was not possible. Let us move to the next. The next thing is 3 by 2 comma infinity. So, case 3, x is less than infinity and greater than 3 by 2. So, in this case what happens to 2x minus 3, positive or negative? Look at this, 3 by 2, 1.5. So, greater than 2 you can take. So, if x is equal to 2, so if you put 2 here, so 2x minus 3, 2 into 2 minus 3, 4 minus 3 is 1 greater than 0. So, if it is positive, then you got to write 2x minus 3. You do not have to write minus of it. Then what happens to x plus 5? So, you have to put 2. So, 2 plus 5 7, that is also positive. If this is positive, then write as it is. Okay, that must be less than 0. Well, do not lose your focus. Alright, we are at the end of this solution. Okay, well, so this looks very tedious, but you have to go through it. Now, you have got 2x minus 3 and minus x minus 5 must be less than 0. So, you have got x here minus 8 here. So, x is less than 8. So, now combining these two, what are you getting? So, you have got 8 and then 3 by 2 I'll take 0 here. Okay, so this is 3 by 2, 1.5, all right, 8 somewhere there. So less than 8 first, less than 8. So less than 8 is minus infinity till 8. So all those values. And the next value is 3 by 2 comma infinity, all right. So 3 by 2 till infinity. Now what is the common region? Common region is this. So 3 by 2 comma 8. 3 by 2 comma 8 is the common region. So that's what I'll write here. So x belongs to 3 by 2 comma 8. Well, so now we have to combine all these solutions. First case no solution, second case we got a solution, third case we got a solution. Now we must find the value of x which satisfies both the things, right? All right. So both quantities within the modulus must be satisfied. Whether x is in this interval, second interval minus 5 to 3 by 2, or if it is in 3 by 2 comma infinity, wherever x is, it must satisfy both. All right. That means we have to find the common region now. We are not writing the union of both. It is not either that or this. It is not or. It is both these values. Okay. A single value of x which lies in the common region of both the intervals is the solution. So for that sake, we will have this. What is the first thing? Minus 2 by 3. All right. So minus 2 by 3 till 3 by 2. So that is the first thing. And the second thing is 3 by 2 till 8. Right. So 3 by 2 is included. So 3 by 2 till 8, yes, right. So that is another region. So what do you think? Either x is here or there, will it satisfy? Do we need to find the common region here? No, we don't. I don't think so, because there is no common region actually, right? All right. So it is not the common region. I am sorry. All right. I will correct my sentence. It is not the common region. It is the value of x which is either here or here. All right. And that must satisfy this inequation. Let's check if you have doubt. Put any value between this. So do you have 0 here? Yes. So put 0. So if you put 0, what will happen if you are taking 0? So this will be minus 3 modulus. And you are putting 0, so that means it is 5. So minus 3 is modulus, no, so it will be 3, I am sorry, minus 5, so that is minus 2. Is it less than 0? Yes, satisfies. Now let me check for a value in this interval 3 by 2 comma 8. So that means 3 by 2 is 1.5, so 2, 3, 4, 5, I will take 3. So if I take 3, then this will be 6 minus 3, which will be 3, and if I take 3, this will be 8. So 3 minus 8 is minus 5, less than 0, right? Yes, satisfies. All right. So that means x can be either here or there. It will satisfy the inequality. Will it satisfy or not? Yes. It can be either here or there, or union. Yes. So therefore, the final answer is x belongs to minus 2 by 3 comma 3 by 2 union 3 by 2 comma 8. Look at this 3 by 2, it is in both, correct. So 3 by 2 can be, understand the logic. It is from here till 3 by 2 and 3 by 2 to 8. Now check for 3 by 2. If 3 by 2 is also included, can you have x equal to 3 by 2? That is the only thing. See, we got this interval, and after 3 by 2 also we got till 1.5, 1.4999, and after 1.5111 is included in that. All right. So what about 3 by 2? So if that is included, then we can write the full interval, because even the point 3 by 2 is included. Let's check. So put 3 by 2 here. 2 to cancel, 3 minus 3, you will get 0. And if you put 3 by 2 here, 3 by 2 plus 5, see this is becoming 0, and 3 by 2 plus 5, that will be 3 by 2, LCM is 2, this will be 10, 10 plus 3, 13 by 2. So this will be 13 by 2. So that will be minus 13 by 2. Is it less than 0? Yes, obviously. So at 3 by 2 also it satisfies. So even 3 by 2 is included. Therefore, we can write it as interval from minus 2 by 3 till 8. Correct? So this region and that region combined together with union we are writing, and even 3 by 2 is included. Therefore, we can write it continuously. If 3 by 2 is not included, then this is the way to write. It's not included here, neither it is included here. Therefore, it is written with open brackets. Now we can close it and write it together. Well, therefore, minus 2 by 3 to 8 is the right choice, option C. Well, look at this question. This question is very interesting because this is x minus 1 and even this is x minus 1. That's a hint for you. So you have a easier method. Well, look at this. You have x minus 1 into x square minus 5x plus 7 less than, yes, x minus 1. So what you can do with this x minus 1, you can take to the other side, correct? So that becomes minus x minus 1 and less than 0. Alright, so that's what we will begin with. Now you have x minus 1 here as well as here. You can take it common, write it only once. Why to write it twice? Correct. So what remains out of this is, out of this factor, what remains if you take this out? Only this quadratic equation, correct? And you are taking this x minus 1 also out, common. That means what remains here? 1, and that is less than 0. Don't forget this. Okay. Next, this is x minus 1, and you have got x square minus 5x plus 7 minus 1, 6. Yes. Okay. Now factorize this. So what are the factors you are getting here? This is x minus 2 into x minus 3. Am I right? So minus 2x minus 3x is minus 5x. 2 into 3 is 6, and minus and minus will be plus, correct? Okay, you can check it. That should be less than 0. Alright. Now take these three things individually. If x minus 1 is 0, x is equal to 1, and if x minus 2 is equal to 0, x is equal to 2, and if x minus 3 is equal to 0, x is equal to 3. What did we get? Critical points. Therefore, x is equal to 1, 2, 3 are critical points. Well, what happens after getting the critical points? What does these critical points do? They divide the real line. So let's divide the real line. So you have got 0. So 0 is not a point. So 1, and then you have 2, and then you have 3. So minus infinity to 1 is the first interval, 1 to 2 is the second, 2 to 3 is the third, and 3 to infinity is the fourth. So totally 4 intervals you are getting here, and in those 4 intervals we have to check, alright, whether this will be positive or negative. Alright, So we have to check where it is negative. Let's do it. You put any value below 1. Okay. So below 1, you can put 0, you can put minus 1, you can put minus 2. So easiest is 0. So if you put 0 here, this will be minus 1 and minus 2 and minus 3. So what is it? Minus plus 2 into minus 3 minus 6. Is it less than 0? Yes, less than 0. It satisfies, correct? So in this interval we get less than 0. So that interval is accepted. Which interval? Minus infinity to 1. And what about 1 to 2? What about in 1 to 2? So here it is negative, and that's what we needed. We got it, satisfies. In 1 comma 2, you can put 1.5, that means half. So if x is equal to half, what happens here? Half minus 1 is minus half, and half minus 2 is minus 1 and a half, correct? Minus 3 by 2. And if you put half here, minus minus 5 by 2. Yes, yes, minus 5 by 2. Now once again minus and minus is plus, plus into minus is minus. There also it is negative, correct? There also it is negative. And then what about 2 to 3? What about 2 to 3? So in 2 to 3, you can take 2.5, correct? So 2.5 is 5 by 2. So you can take 5 by 2 here. If x is 5 by 2, or what's better for you? You will take 2.5. Okay. So whichever, it's same. So if you put 2.5, this is positive, correct? You will get 1.5. And if you put 2.5, you will get 0.5, both positives. And if you put 2.5, this will be negative, correct? So positive is positive into negative is negative. There also it is negative. Well, now let's go to the last one, 3 to infinity. So what happens in 3 to infinity? So if you put any value, you put 4. So if you put 4, this is positive, correct? So that is 4 minus 1, 3, and 4 minus 2 is 2, 4 minus 3 is 1. So you are getting 6, and that is positive. It does not satisfy. So here it is positive, 3 to infinity. So what's your options? What are your options? Your options are minus infinity comma 1, 1 to 2, 2 to 3, correct? Alright. So what about 1 to 2? I have a doubt here. Okay. So 1.5 I will put. So what about if you put 1.5? I am just checking this. Okay. So 1.5 minus 1 is 0.5, positive. Yes. And if you put 1.5 here, that will be negative 0.5. And if you put 1.5 here, 1.5, that will be minus 1.5. Look at this, both negative, that's positive. So it will be positive. So that is also not accepted. So this is positive, I am sorry. So if you are putting 1.5, any value between 1 and 2, you are getting positive. That is not accepted. It must be negative, correct? So which values are accepted? The values where you are getting this product negative. So you are getting here as well as here. So x belongs to either minus infinity comma 1, after 1 you are getting positive, but in 2 comma 3 also you are getting negative. So 2 comma 3, either x must be here between minus infinity and 1, or it must be between 2 and 3. So union of these two. So minus infinity comma 1 and 2 comma 3 is option C, and that's the right choice. So this is a different method if you have product of 3 factors. All right. So if you have factors, find the critical points, divide the intervals, check where it satisfies the inequality. If it was greater, then these two intervals you had to write here. Well, I hope you understood. Well, all right. So let's look at the next thing. So, well, thank you very much for watching, and questions of this type are very easy to solve, but other questions please go through again and practice them very well. Take down the notes of all these things, note down the points, and solve as many questions as possible. Nowadays it's not necessary that you have to refer this book or that book. You will get everything at your fingertips. Okay, so you can Google and get any material. All right, so gather as much questions as possible and try to solve them. You will have all the questions similar to the types that I have solved, so you can try by yourself and try to solve maximum questions within lesser time. Okay, so that's the way you have to practice. So I wish you all the best for your practice, and thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.